Purpose of this WebEx recording is to walk through and demonstrate the flow of taking data that represents a circuit, either as its voltage profile, current profile, it could even be its spectral energy content, and use that as a source inside of ADS and stimulate other circuitry in order to analyze metrics and make sure that you're meeting spec. It's a great way to protect your IP and not have to use actual transistor level models to do your simulations if we can just represent it with some sort of measurement-based or synthesized or simulated data. An example of this might be this data here, where a current source is described as a piecewise linear source between the nodes of VDD and 0. And so we have columns of time and current values, and you can see that we're stepping every picosecond. So this HSPICE piecewise linear source was created to represent that circuitry or that silicon. And what we'd like to do is to be able to apply that data as a source to drive other circuitry and then look at the analysis with that data being used as the stimulation for our network. So that's the overall goal of this recording. And let's go ahead and begin by talking about a potential example that this may be used for. Let's say that you have a representation for your power delivery network, and you have a set of data that describes what the switching network looks like, say for an FPGA or some sort of sync, all right? And then you want to look at, say, the voltage ripple on your power rail. Well, this current profile, this DIDT, while it is switching times that impedance profile of the PDN will give you what your ripple on your power rail would be. So this source described as either a voltage or current profile is critical to that type of analysis. So let's go ahead and talk about the format that we want to convert this to. We want to get that data into what is known as timed MDIF or TIM MDIF format. And you'll notice that the syntax for that format has a begin time data line, and then it has an options line, and then it has basically a format line. Now this option line has defaults, so it's not absolutely necessary, and then it ends with an end statement. If we scroll down in the ADS documentation to further describe this data block, you can see again the begin time data, the option line format with a description of the properties, and the format line and the description of the properties there. And then we can take a look at an actual example. Again, this line here, all right, has defaults, and so you can get away without specifying. And notice that it expects a voltage here, so even though we put in a current, it'll read it in as a voltage, and that's fine for the expression, because if we put it in an IT data set, it knows that it is a current. Okay, so let's go ahead and open up that piecewise linear source that we showed. This is an example of more data that could be brought in. But let's open up that piecewise linear source into Excel and edit it and put it into the time MDIF format. So I'm going to open up Excel here, and then we're going to browse. Basically to this example file that we just saw in Notepad++. And we're going to want to choose the type of data and how we're going to separate that data. So we want to make sure the radio button for delimited is selected. And then as we move to the next import dialog box, we want to make sure that we have both tabs selected as well as the space delimiter selected. And this gives us an example of what the data is going to look like. And then we can hit finish. All right. So we see again that this is a current source between the nodes VDD and 0, and it's described as a piecewise linear source. And then we have time data and current data, and you can see that we're stepping every picosecond. Now, something that cannot be overemphasized is how important it is to make sure that you have the resolution on this data to see that 1 picosecond time step. You can see that in scientific notation and having 2 decimal places, the data is repeated, and this will cause an issue in using it as a source within ADS. We cannot convert this to a data set. It cannot read in the TIM-MDIF data if we don't have the appropriate resolution and we have time steps that are repeating itself. So one of the first things we want to do is make sure that we have enough resolution on this data. So I'm going to come up here and select the first point, go down to the bottom, select the last point, and we reformat this column of time data. And we want to select scientific, all right? And then we're going to apply 4 decimal places to this so that we can see that picosecond resolution. All right. So nothing's really changed at the top as far as the number that's being displayed, but as we go down to the bottom, rather than these numbers replicating each other and rounding off because of the 2 decimal places that was being displayed, we can now see that we can see the picosecond step even up to the very end of the data. Please make sure that when you request, say, a piecewise linear source or someone's making measurements and recording that data, that you get the data with a fixed time step in it, which will remove the errors of interpolation or extrapolation, and that you have enough resolution on the data that you can format it in such a way that the time values do not replicate each other by rounding off. Next thing we want to do is get rid of these continuation lines here in this HSPICE piecewise linear source syntax, all right, so that we can continue to convert this HSPICE piecewise linear source data into the TIM-MDAF. Let's go ahead and take this entire column here, and we can erase it and get rid of it. All right. And then we know that we have 2 lines that we need to insert here. So I'm going to insert an additional one. All right. And we're going to come up here, all caps, begin. Second column, we'll put in time data. All right. Go ahead and make this a little wider. All right. And then this next column is going to be a percent sign. Couple of spaces. We'll type in time. We'll type in voltage. Actually, this is current. It'll read the expression as voltage as the time MDEF because that's the expression it wants. And then we can actually get rid of the rest of this. All right. And now we have the necessary format and header lines for the TIM-MDEF. And we need to go down the bottom and put the end statement to end this block. So we'll get rid of the close parenthesis, all caps. And now let's go ahead and save this. Go back up to the top, make sure it's correct. File, save as. and it has the appropriate directory on this, and we're going to save it as a text file, and then we're going to copy it and put the TIM extension on it so that you can see the difference in using those two, and you can discern the warnings, and that you can move forward even though it's in a text extension. And we'll show that in a second. All right. So what I'm going to do is to actually save this to another name. And we'll call it my PWL and do the save. And close out Excel. Very good. So now that we've done that, we can use something known as the data file tool. And this data file tool can be used from either a data display or from a schematic. Under Tools, and go to Data File Utilities and Data File Tool. And it gives us these two dialog boxes. So what we want to do is read that TIM MDIF file that we've manually created the correct header lines and syntax for, and read it in to a data set in ADS to be used in the IT data set source. So we'll browse to this My PWL text. All right, and we'll select MDIF for the file format, and then the subtype we'll select TIM MDIF, and then we want to give it a data set name. So we'll call this my underscore PWL. All right. Now, since this has a text extension on it, we're going to get some warnings here, and we're going to go ahead and just move forward in creating the data set. So we'll read that file, and it tells us that we see a suffix of txt, and we expected TIM. Do we wish to continue anyway? And we'll say yes. And it tells us the file read was successful over in the status window. We can view the data set and see that it did bring over time, and since it's a TIM file, it recognizes the voltage, even though we place current, and that's okay. We can still handle that expression of voltage there and know that it's current. So we'll say okay. So that shows the warning. Let's go ahead and go back and take this file and copy it. Paste it. And then we'll edit this. And put a TIM extension on it. And now it's recognized as a TIM file. Let's go back to that data file source. And we'll browse to the one with the TIM extension on it. And we'll select MDIF, TIM MDIF. And then we'll call this My PWL1 and create that data set. Now we don't get the warning because we've used the proper extension. We view the data set, we get the same results. So that's the data file tool. So now that we've done both of those, we can go ahead and move that newly created data set from the TIM MDIF file, which was restructured from the HSPICE piecewise linear source, and read it in as this source. So let's go ahead and do that. So we want to set and browse to My PWL. data set, say open, and say OK. Now this is voltage, even though it's on an IT data set, and that's fine, and we're not driving a PDN or anything. We're just going to keep this as a 1 ohm resistor to demonstrate how to create these sources. But something that is critical is under the transient simulation controller, you want to come in under integration tab and make sure that your time step control method was fixed. Again, I can't overemphasize how important it is to have your time data in the proper resolution so that you can see the time steps and that you ask for a fixed time step so that we cut down on the amount of interpolation or the amount of extrapolation that needs to happen. And we avoid any errors that are caused by that. So the default is usually trunk error, and you want to switch this to fixed. And then lastly, in order to not have to use a current probe in this circuit, you can simply come in under the output tab and go make sure that pin currents are checked, and then select the source and select the pin on that source and add it. And when you do that, the results or the output of the data set will have the current at this pin 1 on source 1. All right, so 2 key things on the transient controller. Make sure you go to a fixed time step, and you can also see that we have a max time step of 1 picosecond and a min time step of 1 picosecond, and we're at a fixed time step under our integration tab for convergence, and then we've selected to save the output out of the source pin 1 so that we can save the current to the data set. Let's go ahead and simulate this now. And we don't get any errors, and we have a table here, a list table here of the time and current on this, and we also have on here this current waveform. All right, next thing that we can do is we can zoom in on this current waveform if we desire to take a closer look, and zoom back out. All right, and that is how you take data that represents your sink or your source via timed waveform, whether it's voltage or current, and apply it to these time data sets. So let's go back before we look at another source that we can use. And if we just come in up to this filter window again and type in data set, you'll see the different sources that can be used as data set. We've used the IT data set, but you could also have voltage time data, current harmonic balance data, voltage harmonic balance data, or power spectrum data set, and these other ones as well. Okay, and what we did was take a piecewise linear source from HSpice, but you may get this in a saved oscilloscope data that is CSV file, and you can use that and just convert it to the proper format of the MDIF TIM file, and then they can be brought into the IT data set or VT data set. If you simulated to get the data, and you could have even used a harmonic balance controller, then you can bring in this harmonic balance data sets of the data and use it as a source. So once again, before we go to the second source, I just want to emphasize again, fixed time step is important, and having the number of significant digits and decimal places is also important so that you don't have time steps that are repeating values. For grins, let's just go ahead and come in and browse to the other data set, which was created from the TIM file and was called myPWL1 instead of myPWL. And if we simulate with that, we should expect the same type of plots here, and we get those. All right, let's go to a second type of source. All right, this second type of source that we're going to use here, all right, is called a user-defined source. So we have a current user-defined, and if we were to go to sources, time domain, all right, you'll not only see the IT data set, all right, but you'll also see these user-defined sources that will be in here as well. Another way to look for these, all right, is to go to this library window here, and under the description, you can also type in data set, right? And it gives you the data set sources and what palette or library they're included in. Could also type in user defined. All right, so here's a current source, user defined, and it's under sources time domain, which is what we're using. Here's the IT user defined in the palette. We're using a data access component here, and we need to choose the proper file, and then the variable and values that we'll be reading in are time for the independent data. All right, and this DAC refers to this variable here, X, all right, which has a, is associated with the instance name DAC1 over here, and we're reading in the expression called voltage. All right, the transient controller is set up the same way, and what we're going to do is use either the TIM format here that hadn't been converted to a data set, all right, or we can use the text format as well. So we'll browse to that, and we'll use the mypwlTIM initially and say open, and make sure you have TIM MDIF here selected, and we'll apply that, and if we simulate this, we should get a similar result, and we do. Now, lastly, we could come in and put in the text file and show that it works the same way. TIM MDIF, apply that, okay, and simulate. Very good. So you have two choices here. You can convert to a TIM MDIF, and then from that TIM MDIF, create a data set, or you can come in and use this IT user-defined source and a DAC and read in the data through the data access component. So I hope you've enjoyed this WebEx recording that shows how to take something like a 8-spice piecewise linear source that describes the current profile or voltage profile of a component, and to be able to apply that as a source in ADS to do further analysis with that data being used as the stimulus source. And that concludes this WebEx recording. I appreciate your time.